Question 3 is showing you a graph on a set of coordinate axes, and it's asking you to find the equation of the line in the form y equals mx plus c. So m is your gradient and c is your y-intercept. Now the y-intercept is the easier bit to work out. If you look here, we have a y-intercept of positive 1. So it's going to be, your answer is going to be y equals something x plus 1. Your y-intercept, which is your plus c value in the end, is positive 1. So we just need to work out what goes in front of the x here, and that will be your gradient. So gradient, in general, is your change in y over your change in x. In this case, if I draw a little triangle, and I can do it anywhere, if I draw a triangle here, my change in y is 2, that's a change of 2 going up and down. My change in x is 1, that's 1 going across, so my change in y divided by my change in x just gives me 2. Just check your sign at the end. If it's going up from left to right, it should be positive 2. If you work out your gradient, but then you realise it's actually coming down like this, you've just missed the fact that it's a minus. Okay. In this case, it should be positive 2. So y equals 2x plus 1 is your final answer. So we've worked out the gradient, we've worked out the y-intercept. If you're wondering about how do I know where to put the triangle on here, as long as you go from one distinct point to another, let's say I did a different one that was a bit bigger. Even if I do that, my gradient would still be my change in y, which would be 4, over my change in x, which would be 2. So my gradient, which we represent as m, would be 4 over 2. That still gives me 2. So no matter how big your triangle is, as long as you do your change in y over your change in x, you're going to get the gradient that you wanted. Okay, question 4 asks you to calculate an estimate of the mean. The reason it's an estimate of the mean waist size is because we've got group data. So like for example, these 24 people, all we know about them is that their waist in inches falls between 28 and 32. They could all be 29, they could all be 31. All we know is that they fall somewhere in between there. To find an estimate, we will use the midpoint. So 28 to 32 we'll use 30. 32 to 36 we'll use 34. 36 to 40 we'll use 38. And 40 to 44 we'll use 42 as our midpoint. So if it's group data and you need to estimate a mean, you need to use the midpoints. If there's a question where they just gave you like a value rather than group data, working out the mean would be the same, what I'm about to do. It's just that if it's group data, you need to do this first step where you work out what the midpoint is. Okay, so, quick change of pen. Let's try and get that in focus a little bit better. If I want to work out the mean from here, I create a third column at the end. So mean from a table, whether it's an estimate or not, whether you've had to find a midpoint or not, you create a third column. We times through all of these values. So 30 times by 24, which gives me 720. I've got 34 times by 12, which gives me 408. We've got 38 times 8. 38 times 8, I'm just going to start using the calculator. 38 times 8, which gives you 304. I'm being a bit lazy here. 42 times 6, so I'm just going to use this because it's a calculator paper, so you can. Gives you 252. So, to find the mean from a table like this, we've used the midpoints because it's an estimate, but to find the mean, it's the sum of your third column. Let's write this out. Divided by the sum of the frequency. So the sum of my third column, I'm going to do 720 plus 408 plus 304 plus 252. The sum of my frequency, well it tells you in the question actually, if I add all of these together, I get 50. So my estimate of my mean is 1684 divided by 50. So let's say I just do that and press divided by 50, which gives me 33.68, which is exactly what the mark scheme says, because they want an exact estimate. So it's an estimate, but if you do the estimate properly, it should come out exactly as this answer. Usually I'd be careful about putting your units in as well, but because it actually says inches on the answer line, there's no reason to write it in again. So the next bit, belts are made in sizes small, medium, large and extra large. Jenny needs to order more belts in June. The modal size of belt sold is small. You can see that's true, it's got the highest frequency, so it's the one that appears the most, or the modal size. Jenny is going to order 3/4 of the belts in size small. The manager of the shop tells Jenny she should not order so many small belts. Who is correct? Well, if we look at it, out of 50 customers before, 24 of them had a small belt size. So 24 out of 50. If Jenny wants to order 3/4, we just need to show that this is smaller than 3/4. Now, you can do this in a few different ways. But if we say that 3/4 is the same as something over 50, that's not going to give you a particularly nice number, this, but if we do that, that's the same as 37.5 over 50. One way of doing it is showing that 3/4 is 37.5 out of 50. So 24 over 50 is actually quite a lot smaller. So your reason is that the proportion of belts bought that are size small was 24 over 50 in May. This is much lower than 3/4. 24 over 50, whichever way you want to do it, you just